Okay, so our today's class will discuss, well, actually it's the second part of what we planned for for last week. But due to the time limitation, we haven't covered it yet. So I move it to the fifth weeks of the class. So this week, the title of the discussion is Decision Making Using AHP. Okay, decision making is an activity that have several processes inside it, and AHP is analytical hierarchical processing. It's a tools that is quite famous, being used to help the decision making, and sometimes we call it decision aid because the decision itself, it still depends on the user, but AHP can help to aid or guide the decision. Okay, and well, okay, I I summarized this slide from a book that I will show you later. Well, in this is a very concise and um, practice type of books. Not many theory inside of it, but I think there is a theory that explain what is AHP, but the focus of this book is more like tutorial style books. So I think it's good for you that want to really have a hands-on experience on the tools and applied it on the decision-making activities. And I will discuss chapter 1 until 3 of that books. But due to time limitation, again, there is several topics in that book which is I think it's very useful if you want to use it for either in practice or industry, in your company, or in your research. So I will suggest you to read the rest of it for your own study purpose. But for this one, we will discuss the earlier part of it to give you a glimpse, understanding on the tools and how it can be used. At the end of the session, we will try a software. Well, okay, AHP can be calculated manually, but for the if you consider more factors in your decisions, when your decision becoming more and more complex, you may need to use a software or a tools to help you to calculate all those parameters being considered in the AHP. Okay, so those are the plan for today. Discuss the theory first and then try to use some tools to do it. And course outcome for this topic, we covered 2 course outcome. It's still considered as how you can formulate as a mathematical models, because yeah, it's involved many mathematical inside of the AHP itself, even though we will solve it using a software later on. Okay. Okay. This is the author of the books, Professor Enrique and Pereira Royas. They published the books in 2016. So I really appreciate what they write here, so that I think it's a good it's a nice idea if I can cite it for you, the statement that they make for really related to the AHP or analytic hierarchical process. So this book mentioned that, well, you know that human beings, everyone make decisions, right? Time to time, whether it's individual decision or group decisions. And we normally consider that decision making is a rational process, a process that takes rational steps by, let's say, analyzing the problems, knowing the alternative solutions, and then we will try to select rationally among those solutions. Okay, but somehow several studies mention report that sometimes when human beings make decisions, it is many bias might involve. This bias from physiological studies is known as cognitive anomalies, or yeah, for simple we can say bias. Cognitive bias will make the decisions especially for modern problems, which is more complex, have many layers of considerations, is extremely difficult. Okay, because one person might have different cognitive different bias with the others. So in order to but we still want a decision. When you make a decision, the decision should use a methodology that let's say straightforward, easy to understand. The decision that being made is effective. It can be effective because it's already considered several factors objectively, address several criteria related to the decisions and the alternatives, something like that. And we want to have a methodology to make decision that also somehow they call it here safe, or it's methodology driven. Okay, it's proven step by steps. It's already proven and it's being formulated well, something like that. Okay, and one of those methodology it is called the analytical hierarchical process. So basically, it's well established method already. It's I think introduced by Professor Sati in 1980, and it has been adopted by a large number of institutions in the world. So then, first of all, we start from the philosophical perspective first. Why do we need another decision making methods? It means like why do you need a new step-by-step methods to make decisions? Meanwhile, everyone make decision several other way. Frankly said, for example, when you are in the company, you may involve in several managerial roles, managing people, making interpersonals or informationals and decisional activities. It means that activity related to decision makings is one of fundamental skills that a manager should have. Okay, so well, a good decision will lead your company to whether your company or your firm will succeed or fail. Okay, so before AHP, so before 1980, well, decision making in individual level or decision making process is already being studied well as also, but mostly the decision making considered as comprised of 3 steps. They should be considered intelligence factors of the decision makers, the design of the problems, and the selection and implementation of those alternative solutions. Okay, and normally during those stages, we will go through several process. For example, when you face the problem, of course, you want to ask first, oh, what decision would we make for these problems? And then the decision making process normally involve a stage like what kind of alternatives or solution that you will propose, and what kind of criteria for each of those solution that you will consider. Okay, and the selection of those alternatives are normally applied to find or to choose the best alternative among them. So finally, later on, you will lastly implement those alternatives that you think as the best decision or as the best solution for the problems that you want to solve. Okay, those are the basic philosophy of decision making process. But since the decision is normally made by human, again, it's not always rational. The decision making by human is sometimes much influenced by cognitive bias. Okay, so there is a bias that might relate it to each of the decision maker. So now when you say that, okay, this decision is rational and objective, you cannot say that again, since the decision maker itself will have their own personal bias. Okay, and so AHP tried to come with mechanisms to cope the rational or cognitive bias with those 4 steps of objective decision making process. Okay, so okay, then we come up with there is many decision making methodologies that being considered, including perhaps one of the most popular and straightforward and easy one is like when you want to make a decision, sometimes you will list what is the pros of my decisions, what is the consideration of this decision, right? Let's say when you want to take example, when you want to go to when you want to make a decision whether you want to rent a house or buy the house, it's a decision that will have pros and cons for each of those decisions, right? So one of the best or famous method and very straightforward is that, okay, if you want to buy the house, what is the pros? Okay, for example, if I buy the house, I may the pros is I have it, right? That become my assets. Okay, and when I buy the house for the long term, the housing price might be will be predicted increase, right? But what is the considerations? Consideration maybe do I have the initial money to pay the down payment, for example, if I want to buy a house, or is my salary is enough to pay the monthly interest of the payment, something like that. Is the house that I want to buy is at the location that I want? For example, normally we want the location near the public transport and so on and stuff, but the price will be expensive. But when it's a little bit far away, it's be more cheaper. So those are pros and cons lists. That's the most simple and straightforward. However, This method, as you can see here, has limitations. Okay, has limitations and it can be improved by uh, uh, how to say it really depends. It really depends on the one intuition of the decision maker, because sometimes people, like when they make their pro and cons list, will be so subjective. So there is a lot of flaws might be happen there. Okay, and whenever your decision is getting more complicated, the number of alternative and factors that you want to consider, the decision making, the cognitive bias on your decision is getting larger and larger, and it's getting more and more difficult to really decide for the best solutions. Okay, and normally we will encourage several methods of decision making. For example, several that it will be depends on the areas such as economics, OR. This is the tools like OR tools, probability and statistical tools. They have their own decision making and decision aiding tools that can be used. For example, the one that we already learned previously, created as a mathematical models, and then we plug all the constraint, plug all the objective, and input all the data. Then let's say the operation research and the mathematical modeling approach will give you some suggestion based on the formulation that we made. But for now, that one is more, how to say, um, straightforward, using computerized, and not much take the human cognitive side of it. So those decision is, if we can divide it into the quantitative and the qualitative approach, those are more like quantitative approach, which means that we just plug the numbers and then they will give you some suggestion based on the number that you put. Okay, but for today we will learn how to embed the um, the human perspective into the decision making process. This tools is called the AHP. It's developed by Professor Thomas Sati in 1980, and well, it allow that this mechanism will allow us to structure the decision hierarchically, so it can reduce the complexity. Hierarchically means that they will give you the step by step on how you can show the relationship between. In decision, we have the component of what is your objective, and then what is your the criteria you want to consider for this objective, and then what is the alternatives. Okay, for example, in the decision that choosing whether you want to buy home or rent a house, that one, right? Those are the alternatives that you want to select. The goal is to make the best decision about these housing problems. Okay, and then the alternatives, sorry, the goals, the alternative. Now, what is the criteria? For example, the criteria may be your economics capability, and then your housing needs. Okay, and then your a family consideration, for example. Those are alternative. Those are the criteria that you want to use to select those alternative decisions. But we will give you more simple examples up until here, I think I hope that can give you a good introduction about what is decision making, methodologies, and how AHP position in those topics and discussion. Okay. Up until here, for students that already joining, what do you think about these tools? Have you heard about it before or not? Anyone already learned AHP before?
Not yet, sir.
Oh, yeah, Jeremy, where do you learn AHP?
Not yet, sir.
Oh, not yet. Okay.
Yeah.
Okay, so it's a new thing for you. Okay, but it's okay. We will really start from the basics. We will cover all the theory, and then we will try to implement it later. Okay, now we go to the AHP basic theory. Okay, so as I mentioned earlier, that analytic hierarchy process, so you will use a hierarchy to hierarchical process to do your analytics. Okay, so first, the AHP, you need to develop a hierarchy. Okay, hierarchy, it means the structure of your decisions. Okay, for the basic AHP, there are three structure that you need to define for every problems that you want to consider. First, you need to define the goals. Okay, the goals is what do you want for what kind of solution do you want for your problems. For example, if you want to, later we will discuss about buying cars. Okay, buying cars, so the goal is to buy the perhaps the best car based on the criteria that we will discuss later, from the alternatives that we have. Okay, so the goals is some things that you want to achieve based on this criteria, based on according these alternatives. Okay, up until that, I hope it's okay. And then you will have to define the criteria to support your goals. I mean, like to achieve this goal, what kind of things you want to consider. Okay, what kind of things you want to consider to define these goals. Okay, it's like if previously we talked about objective functions, objective function is the goals. Criteria is the one that parameter that you use to calculate this objective function. Okay, that will affect your objective function or affect your goals. For example, if you want to buy cars, again, the criteria of the best car that I want to buy, maybe first is the cost, how much it price, and maybe the comfort, whether the car is comfortable to use, easy to drive, or the safety feature, that's important also for a car. Okay, and those are criteria. So I hope you get the idea of it. And then based on those criteria, you will given or seeing several alternatives, right? Several, for example, in this case, if you want to buy the best car, so you may already take a look based on those three criteria that you want, based on the, let's say, price range, comfortable and style, and safety. Then you come up with several brand. For example, let's say Toyota. I don't know what's the series there. Maybe Honda, right? Honda sedan, and then what else? Maybe sport car like BMW. Okay, those are alternatives. The car that you want to select. Okay, and defining this is the basic of using AHP methodology. Okay, and then after that you can move the second, third, and the final step, in which we will learn later. You will assess among the criteria. So first you have the goals, right? The goals. After you define the goals, you need to assess based on this goal. Okay, this goal, which criteria among these criteria is more important to the others. Whether it can be the same, but it can be one is more important than the others. So those process we call assessing relative weight of the criteria. Okay, so this part. And then after you assess this weight, let's say you want this criteria is more important, this one is less important, sorry, this one too, this one is the most less important. So like this, those are the assessing the weight. And then you can move to assess this alternative, assessing the alternative. Okay, assessing the alternative or the solutions with respect to this criteria. Okay, and there is another process for that. And then at the end of the process, you will have the overall priorities of each alternative, so that you can use the tools to select which alternative will be the best alternative to achieve your goals. Okay. Okay. Next. Yeah. Let's dig a little bit deeper on the examples. Take example of purchasing a new car, right? I already tried to introduce this one earlier. We want to purchase the best car, among or based on the three criteria. Let's say the cost of the car, the comfort of the car. So it's a subjective matter. So it will be really depends on the cost. Maybe can be straightforward because the cost is not subjective, but the comfort of one car cannot be quantified, right, with numbers. So it should be coming from the cognitive bias of the decision maker. And the safety feature also relative, even though it has the parameter. Let's say it should have the airbags should working, and maybe now there is like a driving assistance, a brake, something like that. But it's still, I think, still considerably subjective matter to be assessed. And let's say we want to have those three criteria. So now you already define the hierarchy. First, the goals to find the best car among these criteria, and then you already select the criteria: cost, comfort, and safety. And then for simplification, let's say we want to evaluate several alternatives. Okay, you can assess a lot of alternatives using these tools, but because we want to dig deeper on the calculation part of it, so let's use for now just two alternatives. Okay, car 1 and car 2. Okay, I'm not mentioning the brand, that's just for the example proposed. Okay. Well, okay. To analyze the AHP, to analyze the decision of purchasing car using AHP, at least there is 6 steps that we will learn today. First is the first step that is already discussed in this slide. Develop a model in which it consists of hierarchy, structure of goal, cost, goal, criteria, and alternative. And then the next step, we will calculate, or here we mention it, derive priority for the criteria. Okay, calculate the assessment for the priority, the score for the criteria for this one. Okay, and then after that we will calculate or derive local priority or score for the alternative for this one. Okay, and after we have those two calculations, we will calculate the overall. So first is only consider the criteria, second we will only consider the alternative, then we will combine those score and perform the model synthesis, we call it, to really see which one is better between this alternative and this alternative, considering the criteria. Okay, and we also need to know how to do sensitivity analysis. Later I will mention that. Normally AHP tutorial will stop only until point 4. Okay, because that's all the process until you get the decisions. But the which also important, actually, step number 5 and number 6, in which you should aware that this decision-making process is a really subjective matter. So you need to really careful, so that you need to conduct a sensitivity analysis before you do the final decision. Okay. Okay. Let's start from the first one. The first step is assessing criteria, the importance between one criteria to the others. Okay, we use the notation C for the criteria earlier, right? And the criteria that we have before is like, for example, the cost, the comfort, and the safety. Okay, in this step, you need to give a score, comparing one criteria to another criteria based on its importance. Okay, importance. Okay, we want to assess which criteria is more important, or equal important, or very strongly more important than the other one. Okay, so we use this intensity scale. So it is called intensity scale. It is available in the explanation from the book from Professor Sati. We use this scale to score those criteria among those criteria. So it's a criteria pairwise comparison. So you need to score one criteria with the other one. Okay, and the importance is symbolized with the number 1 until 9. Okay, in which 1 means it's equal important, 3 means moderately important, 5 strongly important, 7 very strong, and 9 is extremely important. But a number between this and this also available, which basically means just the intermediate value between equal and moderate will be 2 or 2 something. That's also fine. Okay. Okay. Now let's take example on how do you how can you give those relative intensity between one criteria to another one. Okay, first, if you notice that we only give the importance to relative intensity or the score to the cell here that is shaded in gray. Okay, why? Because like this. But before we go there, for the same criteria 1 and criteria 1, of course, the importance will be equal. So it will be 1, 1, 1. So the criteria that is compared to itself will be always 1. Okay. And then now, AHP, using the principle of reciprocal relative intensity. What does it mean? It means like this. When you say that C1, C2, okay, this means like, what is the relative intensity between C1 per C2? If you say that C2 is strongly important than C1, okay, criteria 2 is strongly important than C1, so you will write it 1 out of 5. Okay, so 1, 2, 1 out of 5 here. Okay, I hope you understood that. And you don't have to write again for this one, because it's the reciprocal or the opposite of this value. It will be C2 per C1. So it will be 5. Okay. Okay. I hope you get the correlation between this and this. It's just the opposite, or we call it reciprocal relationship. Okay. That's why we will only fill the part here and here, because when you, let's say, C1 and C3, so it's equal 1, right? So you need to, when you fill this part, you also fill this part. And then the last one, 1 out of 3, you will fill this part, you also fill this part. Okay. Yeah. That is how would you would give the relative intensity of the pairwise comparison of each criteria. Okay. And okay, the reciprocal relationship, well, actually means that when you say that one criteria is more important than the other one, so when you say, let's say, apple is more important than oranges for your life, okay, so later on when they ask apple is strongly important than orange in your life, so the score is 5, right? 5 for apple, 1 for orange. Later on, when you are going to be asked again, what about oranges to apple? This this approach will make sure that the score for your judgments about that will be the opposite of it, 1 out of 5, right? Because previously you give 5 already for the apple compared to orange. Then if you compare orange to apple, will be 1 out of 5. Okay. And again, for this one, for example, you have 3 criteria, right? Other than reciprocal relationship, we also have something called transitivity rules. Okay. Okay. Transitivity rules will also determine whether you fill this table consistently or not. Okay. So basically, transitivity rules means that when you mention one criteria is more important than the others, and let's say C1 is more important than C2, then you say that C2 is more important than C3. Okay, the transitivity rules will check that when you are being asked, this one is more important, right? Okay, C1 more important than C2, C2 more important than C3. When you ask later C1 and C3, of course, C1 will be always more important than C3. But sometimes, because it's a human that make decision, sometimes you will give the value, oh, this one, not less important. So later on, we will have the mechanism to check whether your judgment is consistent or not. Okay, but For now, the concept of transitivity rule is like that. So in by doing the assessment like this, we can make sure that your assessment or judgment for the criteria will always be consistent, and because it's obey the reciprocal relationship and the transitivity relationship. Okay, that's the first step. Compare and give the score to the criteria. I hope everyone already okay with this. Any question first before we go to the next step? No? Okay. So the next step is like, let's try to give the score to the example that we used earlier. Okay, first, we have 3 criteria, right, for selecting the best car that we want to buy. We have comfort, okay, and then cost, comfort, safety, okay. Then we will create the pairwise comparison metric: cost, comfort, and safety. We will compare it, okay. Then let's say this, you want to say that, oh, for cost, I think cost is strongly more important than comfort, so I give 7. Okay, you give 7 here, it means what? It means you give 1 out of 7 here. Okay, that's why I give this area shaded gray, because we only need to fill this 3 score. Okay, then you compare cost and safety. Okay, cost is still more important for me, so I give 3 here. Safety is 1 out of 3. And then the last is I want to give, I need to compare comfort and safety. I think safety is more important, so safety got 3, so cost got 1 out of 3, so you write 3 here. And by default, the diagonal cell should be always 1. So you get the assessment already. And our goal for this one is actually to calculate this, the priority based on our judgment. Okay. To calculate this priority, there is several steps that we need to do. Okay. First, after we give the score, right, for the pairwise comparison matrix in figure 4 here, we already finished the score. We need to calculate the overall the sum of the column. Okay, so 1 out of 7, 1 out of 3. Yeah, I make it into the decimal. 1 is 1.000. 1 per 7 is 0.143. So this is equal this. Okay, and so on. I write all the value below, okay, in the figure 5. Okay, and then I sum up all these columns, okay, and I got this. Okay, so 1 plus 0.143 plus 0.333 is equal 1.476, and do the same way with all the columns. Okay, you got all this total column. Okay. So what do we do? Why do we need to do this? Because this is the step to calculate this priority. Okay, first sum all the columns, and then you need to normalize this table, yeah, this one, by dividing all the cells in the particular column with the sum of its column. Okay, for example, is 0.667. Yeah. This is equal 1 divided by 1,467. Okay. And then this one is equal this one 0.143 divided by 1.476. So you got this. And the last one is this. It's become this one divided by 1.47. Okay. The next column is also the same. You divided 7 by what is this? 11. 7 divided by 11, and you get this one. Do that for the rest of the column. This is called later the normalized matrix. Okay. After you get the normalized matrix here, so normalized matrix we can use to calculate the priority here, priority that we want. You see, here is the normalized matrix, right? The one that from your calculations. Then you calculate the average of this one. The average of this is like 0.667 plus 0.637 plus 0.692 divided by 3 will be equal this. Okay. And this one also the same. 0.097, 0.091, 0.077 is equal 0.88. Okay. And this priority is the result of our second step here, which we want to derive the weight for each criteria. It means that for each criteria, we have the weight here now. So it means that for the most important criteria for me, from my judgments, is here, the cost, about 0.669. And then the second one is the safety, right? 0.243. And then the third one, the last one is comfort, 0.088. Okay. That's the how do we calculate the weights for the criteria. Okay. Don't worry about these computations. You will use software later on. But I think you still need to understand how to calculate it manually so that whenever your software give you some magic number, you still understand what is those number means. Okay. Yeah. Okay, this final weight will be the output of this part. Okay. After you assess those criteria, you need to also understood how to check whether your assessment is consistent or not. Okay, what is consistent or not, right? That's another question. Consistent means because we compare several criteria, right? And it's a human decision, and it's not easy to translate those what do we call it? The relative intensity, in which it's very subjective, right? Equal, moderate, strong, very strong. It's a relative term. Sometimes we can say this one moderate to importance to another, but sometimes we can say strong. And one person have different judgment to another one. So we need to make sure that within the same person, they give the consistent judgment when they compare one criteria or one alternative to another. Here, I will explain a tools or a measurement to check the consistency of one's judgment. Okay, it is called the consistency index, or later translated into CR, consistency rate. Okay. Okay, first the concepts is like this. You can say something is consistent if it is obey the reciprocity and the transitivity rules that I mentioned earlier. Okay, for simply example, when you see C1 is better than C2 and C2 is better than C3, of course, when you ask C1 is whether is C1 is better than C3, you should also say this one, right? But again, this term is relative in AHP, right? You are using like 1, 3, 5 until 9. Is also 1, 3, 5 until 9. So the way you represent this is not an exact number. So you need to have a measurement, a way to calculate how far the consistency is still working in your judgments. Okay, reciprocity and transitivity are being measured here, and from the book of Professor Sati, it has proposed something called consistency index, or CI. Okay, the formulation is like this. Okay, it is lambda minus n. N is the number of criteria or alternative, and this CI later will be translated into consistency ratio, in which we calculate from the CI divided by RI, and RI is a table. It's a table data that you can use as a reference to see whether your consistency is good or not. Okay. Okay. Don't worry about this number and this formula yet. We will implement it. We will see the implementation in the next slide. Okay. Yeah, and then later on, after you calculate the CR, you will compare whether your CR is less than 10% or 0.1 or not. If it is less than 0.1 or less than 10%, you can mention that, okay, it is constitute to acceptable consistency. So you can use those judgment. But if not, you may need to tweak or you may need to ask again the judge or the expert that provide you with the judgment about their answer or consistency. Okay. Okay, now let's try to calculate the consistency of our previous judgment about the criteria of buying a car. Okay, criteria. This we still talk about the criteria. Okay, come back to the previous result. We have this one, right? Pairwise comparison, and then the priorities. Okay. To calculate those previous this one, right? We have this data from the previous calculation of assessing the weight, and based on the priorities, okay, the priorities, we will calculate the weighted columns, so that we will use that to calculate the consistency rate later. Okay, first, this priority, you make it into a one row here. Okay, this value, put it here accordingly. For example, cost, you have 0.669, comfort 0.00x, and then safety is 0.243. Okay, and then you need to multiply. Okay, multiply each value, each value here with the new criteria weight. For example, 0.669 you multiplied by 1, you get this one. 0.669 you multiplied by this one, you get this one. And 0.669 you multiplied by 0.33, you get this one. Okay, this is called the weighted calculation column. So you weight the criteria based on the priority or the criteria weight that we used earlier. Okay, after get this column, you can calculate the weighted sum of the column. So you sum this one here to the right. Okay, total weighted sum. Okay, this is called calculation of the weighted sum. And then, okay, here, figure 10. Okay, and then the next step is go to the CI consistency index calculations. Okay, here we have the weighted sum that we have earlier for cost, comfort, and safety, right? The weighted sum. And we put back the priority. Okay, yeah. For the cost, priority is 0.669. For comfort, priority is 0.088. Okay, and then you divided the weighted sum with the priority A divided by B. Okay, you get this one. Okay, and total of those number divided by the, because we have 3 factor, divided by 3, then it is called the lambda max or the eigenvalue of this formula. Okay, so you need to find this one first. Then after you have this number, you can plug the number into the CI formula. So it becomes 3.007. We have 3 criteria, so minus 3, divided by 3 minus 1. And then you get 0.004. And then we go to calculate the consistency ratio. Is CI divided by RI. CI, you got this one, 0.004. RI, you get from the table. If you have 3 factor, you have 0.58. So you get 0.006. Okay. Okay. Yeah. Then 0.06 means that the consistency rate of this weighted criteria is 6%. So it's less than 10%. So we can say that our judgment regarding to the criteria is less than 10%, means that our judgment is reasonably consistent. So we can continue further with the AHP that we already, the next step of the AHP, which is later comparing the alternative. Okay, that is the third step, checking the consistency. Okay, up until here, students, are you still catching up, or still okay, or it's too easy, sir? Just go, just continue.
Just continue, sir.
Okay, thank you. After you know that the assessment is consistent, so you can plug it here. So this is the value already, right? For goals related to cost, you have this parameter, or for comfort this, and for safety is this, because you already sure that it is consistent. Okay, the next step, now we know our preference about the criteria here. What about this one, right? At the end of the decision, we want to select the car, actually, not the criteria, right? Okay, so the next step is it is called deriving local priority or real preference for the alternatives. What is alternative? Alternative is this one, car1 or car2, right? So you need to assess again the same way with the priority matrix that we discussed earlier for each particular comparison. For example, for criteria cost, you will compare car1 and car2. What will be the value of this one according to the cost? And then for comfort, you will compare car1 and car2. You can put the value here, the priority here. For safety, you also do the same thing. So car1 and car2. Yeah, this called derive the local preference because it's local to the cost, comfort, and safety. So the more you have the factor, the more time you need to compare it. The more alternative you have, the more comparison you need to make. Okay, that's why it is not easy to be done manually when you have so many criteria and alternatives. Okay. Okay. How do we compare it? Right. That's one question. We will use the same scale that we use for the criteria that consists of number 1 until 9. 1 is equal, 3 is important, strong, important, very strong, important, extremely strong, important. That one, the same table one. Okay, and then after we compare it, we need to compare each alternative with each other. For now, we have only 2 alternatives, right? So you need to only compare car1 and car2. But if you have more than 2 alternatives, let's say 3 cars, so you need to compare A first, let's say alternative 1 versus alternative 2, alternative 1 versus alternative 3, and alternative 2 versus alternative 3. So this is the comparison that you need to make when you have more than 2 alternatives. Okay. What about more? Yeah, you need to find all the combination. Okay, so here let's try to let's do this one, the calculations. Okay. As I mentioned earlier, you need to compare it for each of the alternative: cost, comfort, and safety. Okay, if you remember, the comparison is done using the similar these 3 steps, right? Give the score, normalize, and then yeah, put it back here, the value of the priority. Yeah. Okay. Take example, you want to score the car1 and car2 based on the cost. Car1 is the same one here, right? This is the same one. Okay, now car1 and car2, I think car1 is much better in terms of cost. So I put more important, strongly important 7. So this will be 1 divided by 7. Then you're done with the comparison, right? And then to normalize the table, remember, you need to sum this one. Okay, let me delete it first. So you need to sum the column, right? 1 plus 0.143 is equal to this. 7 plus 1 is equal to this. And then you normalize it, right? 1 divided by 1.143 is equal to this. 0.143 divided by 1.143 is equal to this. Okay. Yeah, that's how do you normalize to the rest of the column. And after you normalize, you calculate the priority. This one. Priority is the average of this one, right? 0.875 plus 0.875 divided by 2 is equal to this. 0.1 25 but plus 0.125 is equal this. Those are the priority. And then priority, you put it here. You put it in the original form. Yeah, right. This one is taking from the same value, you see. And this one is taken from this one. Okay, up until here. You got it? The step. It's the same way when we calculate the criteria, but instead of calculating criteria, now we calculating the preference for all our alternatives. And we have for each alternative, we need to do it for each criteria. For example, cost, comfort, safety. You do the same thing. Here you compare for the cost. Here you compare for the comfort. Here you compare for the safety. Okay. Let me try again. For comfort, let's say I want to, this one is 1, this one is 1, right? Car 1, car 2. Oh, car 2 is more comfortable. So this is 1 divided by 5. So you put 5 here. So you put 0.2 here. Is equal 1 divided by 5. And then you need to what? Sum the column. 1 plus 5 equals 6. 0.2 plus 1 is equal 1.2. Okay. And then you normalize it. Divide it by this is equal this. This divided by this equal this. Okay. 5 divided by 6 is equal this. Okay. Normalize it. And then after you normalize, you calculate the priority. Yeah. Average of this one. Then you get this, put it here, and then this one also put it here. You got the preference with respect to the comfort. Okay, do the same for safety, comfort, and cost. So your priority here, if we summarize it, you can put it here. For every alternative, you have car 1 and car 2. For cost, the preference show that car 1 is more preference compared to car 2. But for cost, comfort, seems like car 2 is much better than car 1. And for safety, car 2 is much better than car 1. So how do you select from this one? We cannot decide yet, but at least based on this table, you already have much more information about your decision regarding to each car or to each alternative, localized to each factor. Okay, I hope this calculation is okay. And the last part, okay, well, okay, for this one, you need to also calculate the consistency. Okay, CR, this one also CR should be less than 10%, should be less than 10%, then should be less than 10%. Okay, why is it? Because it's useless if your judgment is not consistent. It will let the decision to become a little bit more biased than the one that you actually want. Okay. Okay, next. Yeah, if you already make sure the consistency, then you can plot the value. Here you have for the criteria that we have earlier. This one is the comparison of car 1 and car 2 relative to cost. Right? You see that for cost, we prefer car 1 than car 2. Right? And for but for comfort, we prefer car 2, yeah, than car 1. And for safety, we prefer car 2 than car 1. Okay. Yeah, based on this value or based on this judgment of the hierarchy, now we can do the model synthesis or overall decision related to this model. Okay, yeah, we already finished all those 4 steps. We have the criterion already. Then we can start calculate the overall priority, right? This one is only priority for criteria. This one is priority for each alternative. At the last step, or it is called overall priority or model synthesis. We combine all those judgments, and we will get the alternative that is actually being preferred based on that judgment. Okay, the process of model synthesis is like this. Well, basically, for each alternative, right? Alternative, this, you need to calculate a score or overall priority. How do you calculate the score? Like this. You will multiply this one, the factor, with the priority that you give for those alternative. For example, related to cost, you will get 0.669 multiplied by 0.875. This one, the first part. Okay, and then for related to comfort, you will multiply this one plus 0.088 here, multiplied by what? 0.167. Yeah. Okay. This one for the cost, this one for the comfort. And the last one is related to safety for vehicle one, right? For car one. Plus again 0.243 multiplied by 0.1. 0.243 multiplied by 0.1. This is related to safety. Then you will get, okay, this is the final score for car 1, which is 0.624. Okay. Yeah. You do the same thing for the car 2, the second car. Okay. Second car. Why I don't just delete all? Okay, sorry. For the second car, 0.669 multiplied by this one now, because this one will be go here, right? 0.669 multiplied by 0.125, this one for the cost. And then 0.88 multiplied by 0.833, yeah, for the comfort. And this one is 0.243 multiplied by 0.9. This one for the safety. And then you sum all of it, you get 0.376. Okay. This is the final judgments of the final priority, overall priority for our AHP model. Okay, based on these settings, it means that based on this judgment that we prefer car 1 because the priority, overall priority, considering cost, comfort, and safety is much higher than the car 2, something like that. Okay. Up until here, any question? So at least you understood those steps. For the calculation, I think you can replay again the video. But for the step, I hope you already get the point up until now. Okay, what do you think? And student, any input, any question before we move on to the next one? No? Okay. Okay. Yeah. Well, we already get the result actually until that step. overall priority or model synthesis. However, the result of AHP is really depends on the weight, right? The weight of the criteria. Okay, and as you know that sometimes this weight is prone to bias, right? Prone to bias. Okay, so it is important to conduct something called sensitivity analysis. Okay, sensitivity analysis is what we can say to perform a what if scenario. What if we can analyze what if the difference or the final result, what is the final result if we change the weight of the criteria. Okay. Oh yeah, we know that. Okay, we already select this value. Why we need to change it again? Yeah, because we want to see how sensitive is this weight. If somehow later you will change that one, how sensitive is this weight? So you will be very sure when you make this decision. Okay. Okay, and it can give you more a concise explanation about your AHP result. Okay, for this step, you need to have understanding about the option, the criteria, and the alternatives that you want to choose. For example, in this case, we try to generate 3 scenarios. Okay, 3 scenarios to understood the weight component of each criteria. For example, here the original scenario is have more tendency to choose cost other than to other factor, right? So you prefer to get a car with less cost compared to less comfort or safety. Okay, but what if you have the same criteria? Okay, what will happen to your judgment? Okay, what is some people have the same criteria for all? I don't have any preference. Cost, comfort, safety, all the same. What will be the result? Is car 1 still be the option that you want to choose, or it will be moved to car 2? Okay, so we just need to conduct the last part, which is called the model synthesis, with this new weight. Okay, last part is we have this one, right? The priority, local priority of each factor. Then we multiply this with this plus this with this, right? 0.33 multiplied by 0.8 plus 0, sorry, not like that. To the right, we multiplied to get the new weight of each car. We multiply this with this plus this with this and this with this, right? To get this one. And for the second part, for the second car, you multiplied 0.3 with 0.125 plus this and plus this one. Then you get this one. Now you can see that if your weight is changing, well, actually the car 2 is more preferable compared to the car 1. Okay. Okay, this is the use of sensitivity analysis to show you the several things that might happen. Okay, another things that is often asked is like, okay, but that one is I already create my judgment using this one. I mean, like I prefer car with less cost, for example. There is cost, the cost is good, the price is good. I'm not really thinking about making it all the same. Okay, so please make the cost still be the biggest factor and let the rest is the same. For example, you put cost is 0.4, 0.5, and then the rest is like comfort and safety is like a quarter and a quarter. And then you recalculate again, oh, the result is somehow, it's a little bit, we can say, the score of car 1 and car 2 is almost the same. You can see here, 0.5, 0.9, 0.49. It's close. The number is like draw, we can say. So based on this, what should you suggest, okay, to the decision maker? Okay, of course, you cannot push people to choose whatever, choose what you want, but you can tell them the result as like this. For example, based on table this one, 13, your original scoring, of course, we already know that you prefer cost instead of other factor. It means that car 1 perhaps the best for you in this condition. However, later on, if you think that all factors should be treated equally, well, actually car 2 will be more suitable for your option in that case. Okay, and then, but if you were willing to make the factor of cost is slightly less until like only 50% of your judgment, it means that either car 1 and car 2 is almost have equal score. It means like whether you buy car 1 or car 2 will be the same if you willing to have less weight about your cost, something like that. That's why we need to have a good sensitive analysis before making the final projects. Okay, and I think, yeah, that is the theory of AHP for today. And well, although the calculation that we calculate previously can be done using spreadsheet or manually using hand, but I would like to recommend that we use software because it is first easier to make sure the consistency, to put the value, and then it's more saving time for your calculation purpose. There are 3 software that is famous for AHP: Decision Land, Expert Choice, and Super Decision. I'm not promoting any of them, but somehow I got the tutorial that is easy to follow using the last one, and including this book also using this software. So we will try to use that one. Okay, I think the next part we will try the software. Okay, but before that, I would like to stop first and ask you what do you think about this AHP? I will pause the recording because after this we will show a YouTube example, and because we will upload this one to YouTube also, so to avoid the content problems. So I will stop the recording here, and we will watch this YouTube. But if you are interested to watch by yourself, I provide the link also here. Okay, this one for the downloading the software, this one for example of the software. Okay, but later after this we will try by ourselves. Okay. Okay, let me stop the recording. Stop, pause. Okay, so now we will start we will try the super decisions, the software for AHP, for our example, the one that we already discussed on how to calculate it manually. So this is the problems that we are going to model in the super decisions. We will have the goals to select best car that we from these 2 alternatives car, and we have 3 criteria that we are going to consider among the selections. Okay, first let's go to the software. After you download and install the software and open it, it will shown like this. You can see that from this it's quite simple. It's similar with the video YouTube that you just saw earlier. First of all, you need to save it and then create the save file here. Let's say we name it car selection AHP, something like that. And then to create the first step is actually the same with what we have in the presentation here. We need to create the structure first, the structures, the goals, the criteria, and the alternative. So to do that, we can do it like here, and then create model structure. We can name the structure. First, there is goals. And then if you want to add more structure, you can click add more here. Okay, then we have criteria, and then we have alternative. Okay, then yeah, to make it separate with each other, now we have those three structures that we want to consider in this AHP or decision making process. And at each cluster, we will put a node here by clicking in the cluster, and you can write the node's name, goal node, something like that, to tell the software that you will have one goals here. Yeah, there is this software can do multiple goals, but we will not discuss that in this session. We just focus on the simple AHP example that we already discussed earlier. And then for criteria, we do the same thing. Click here, add nodes. Okay, now we have one, there is cost, and then there is another is comfort, and then the third one is security. Okay, we basically follow exactly the same example that we have. For the alternative, we can do the same thing by adding the alternative is car number 1, and number 1 is car 1, and then number 2 is car 2. Okay. Save. Okay, now, okay, be careful with that error. It makes you see, the cluster name is how to say, it's not correct here. We want this cluster name actually is alternative as previously, but it's mistakenly being renamed after we get add the nodes earlier. So be careful with the error, because it may the calculation will be wrong later on. So you need to fix it first. Okay. So now it's already correct. The next step is to connect between goals to criteria to alternatives. So there is several ways to make the connections, but one of the easiest way is by using these tools here. You need to wait. There is something. I think there is something wrong here with my. Oh, okay. Yeah, 3 alternatives. Okay. Now here you need to use this one by clicking here, and then click the nodes that you want to connect. For example, if you want to, sorry, You want to connect the goals node. Here, click the show connections, and then you need to connect the goals with the criteria. So you can select 1, 2, wait, there is security tree. Okay, and then put it back here, but you can see there is another error here. Alternative, this one not correct criteria, so you need to delete. Okay. Okay, make it back again. Now to see whether the connection is already proper or not, you can click from here. Click this button to show the connection, and click the nodes that you connected earlier. You can see that if it's connected properly, it will be appear red on the structure of the criteria. Okay, here you can also make sure that the check box is in the correct part. Okay, next we create another connection for this, for each of the criteria to each of the alternatives. So you the same way, you click the cost here, and then you connect it to car 1, car 2, and then don't forget you need to click the white space here to make sure it's connected. Now after like this, then you can move to another criteria. Then this one, the same one, criteria 1, criteria 2, click here in the white space, and then click the security, and then connect it to criteria 1, criteria 2. Okay. Okay. Up until here, you make sure again, check the connection. This one already okay. This one already okay. You see it's appear red here. Car 1 and car 2 connected to cost 1. Comfort also, security also. And you can also check here to make sure again. Okay, the initial value of the unweighted super graphics, as mentioned by the in the previous YouTube that you saw, is by default 1 divided by number of the connected nodes there. But it will be modified after we provide the judgment. Okay, after the structure is being defined well, so now as similar to the manual calculation, here we need to create the first step is derive the priority or weight criteria. As you can see here, we need to make this table, or in this super decision, they call it judgment. So here you can see cost is 7 to comfort, cost is 3 to safety, and comfort is 1/3 of the safety. So to do that, in the super decisions, we go to here, judgment. Okay. Sorry, yeah. Here you need to select the goal nodes for the first choose node here. And then for the cluster, you need to select the criteria. Okay, as mentioned in the YouTube, the previous YouTube, there are several ways to input the judgment. But we just use the simple one for today for example purpose. You use the questionnaire. There is the number here. As you so we need to have 3 comparisons like this, as you see in the shaded area. Cost to comfort will be cost to comfort is this one. Cost to comfort will be 7. Cost is very strong, more important than comfort. Yeah, for this one. And then cost to safety is 3. Yeah. Cost is moderately more important than security. And then the last one is comfort to safety. Comfort to safety is here. So we need to 1/3 is this one, right? Security is moderately more important than comfort. So it's 1/3 and 3 in the safety here. That's the way how do you give the scoring. It's automatically checked the next step, as you can see here. In the manual process, remember, we need to calculate this one, priorities. And as you can see here, the number of priorities here on the right side of the result, it's automatically give you the number of the one that we calculate manually here, 0.669 for cost, 0.088 for comfort, 0.243 for safety. You can see here 0.669, 0.087, 0.242. So basically, these tools can help you to calculate it instead of doing it manually. And also remember that we also do the consistency checking to check whether your judgment is consistent or not. And we also do it manually in the previous part. And as you remember, we got the consistency value is 0.06. And here they also help us to do the calculation of the inconsistent CR, consistent ratio factor, automatically, and you can see the number is exactly the same, 0.006. Okay, so I think these tools can help you very much about that. And the next step after we have this, the value for each criteria, we can move on to give the value for each alternatives or judge the alternatives, right? So here we go to the cost first, the cost, and then remember we do this calculation. So we need to compare cost in terms of cost, car 1 and car 2. So for car 1, we give the cost is 7 or very strong important than car 2 in terms of cost. So this one is only one comparison because we only have two alternatives. And then in terms of comfort, in terms of comfort, you see that car 2 is actually more comfortable than the car 1. So you put here in the red, car 2 is strongly more important than the car 1 in terms of comfort. And the last one in terms of security, here the car 2 is I think it's very strongly more secure based on this example judgment than the car 1. Okay, the same way with previous one, they also help you to check you see here the priority. For example, for respect to cost, we will calculate the priority 0.875, 0.125 for the car 2 and 0.875 for car 1. You see here, the calculation is done automatically. For cost, the priority is 0.875 and the car 2 is 0.125. And the inconsistency index, because it's only two alternatives, it's automatically applied for the transitive, for the reciprocal rule. So for two alternatives, it's always be inconsistency will always be 0. But if you have 3 or more alternatives, this can be raised. But remember, whenever you give the judgment, make sure that inconsistency index is less than 10% as the threshold of the AHP. Okay, and I want to show you another result also. This one for the comfort 0.16, 0.8, exactly the same. And then for security 0.1 and 0.9, right? Okay. Okay, up until this point, you can do something called sanity check, okay, and to make sure that there is no error or warning. And after that, you can also check the super matrix, or well, actually it's now updated to all the, you see, for criteria, we have the priority here that already calculated. For each alternative, with respect to cost, comfort, or security, we already have the value as well. Okay, later on we will calculate the final judgment, or here we call the model synthesis. Okay, for the model synthesis, we can do here computation and then synthesis. Okay, yeah, here you can see that the result of the model synthesis, the normal here is showing the score 0.692 and 0.3. It's basically the same with the calculation that we have 0.624 and 0.3676. Yeah, basically the same with the calculation that we have in the super decision and in the manual. Well, the purpose of this example is actually to show you, well, it is easier to calculate using software, but remember, you need to understood all the process first before you just click using the software without knowing what is really happening there. And for the sensitivity analysis, basically it's the same way, just repeat the same process, but using different weight factor. And I think, yeah, those are the result of the AHP using super decisions. I hope this can give you an introduction to the software. And this software can actually do several more things that let's see another how to say, another topic that is not yet covered for today's class. Okay, yeah, okay. There are more on the use of the AHP instead of only those expert judgment for from one perspective of expert. And in this book, I would recommend you to take a look. There is several topics that I may not able to cover today. For example, the AHP that we see earlier only use 3 simple criteria, but actually those criteria perhaps might have more complex structure, like maybe they have sub criteria, and how to address that one, the software is able to do that. The algorithm, the method of AHP also able to do that. And there is another type of ESP, it's called ratings models. You can also explore about that. And here the CH mean it's discussed in the book in that particular chapter. Okay, and then you can also use the AHP to do a benefit or cost analysis. And perhaps another important topic about AHP is also that you can the decision is most often created or taken by group of individual. So how do you address that? In chapter 8, this book discuss on how group decision making can be conducted in AHP. So I think this is one important chapter that you might want to take a look. Okay, and from that group decision making, there perhaps we can use it for group negotiation, the conflict resolution and stuff. And there is an practical application example of application of AHP in real industry case in the last chapters. Okay, and all of this is also accompanied by the use of the software super decisions that I already demoed it to you earlier. So I think please take a look about that for your own benefit, for your own expand of knowledge. I hope it will be very useful. Okay, I think that is today's discussions. It's a little bit longer than usual, but since we have software and tools to try, so I guess that hope it will be worth the wait or the time a little bit longer. Okay, up until here, I think before I close the session,